welcome back. This is Pankaj here. In the last video, we have seen as to what exactly is a function. We have defined a function, and we also understood two different kinds of function. One was an on-one function, and the other one was a on-two function. Now, people who have not looked at these videos, please go back and refer to that video and then come back to this video. Or if you have already understood and if you know what's a one-one function and an on-two function, you can please proceed with this video. Okay. Now, as I was explaining in the last video that the concept is this much, but proving the question will be a bit tedious. It's going to take a different route altogether. I'm going to take that up and I'm going to teach you how to prove a function to be a one-one function and an on-two function. Okay. What I'm going to do right now is to take a very simple example. I'm picking up this example just to know or just to tell you how to work with these type of questions and what is the concept behind it and how exactly this works. First, I'm going to explain to you the concept, and then I'm going to give you the working rule as to what exactly you need to do to get the solution. Okay, so let's look at the question. There you go. That is a question. It says, if you see, this is an example question from the NCERT textbook, which means it has already been solved, but then too I've picked it up because I want you to understand the concept behind it. Okay. Great. Now it's a one single statement that is being made here. Prove that the function so and so given by so and so is a one-one and on-two function. Now there are a couple of things that you need to catch from this particular statement that's being made here. The first thing that you need to catch is this. This is the real numbers R. Okay, how am I sure that this is a real numbers R and not the relationship R? Okay, you would have noticed this in this NCERT textbook. Whenever he talks about relationship R, he would write it in not bold letters. Okay, and whenever he's talking about real numbers, he would write it in bold letters. Okay, so that's my real numbers R and this is my relationship R. But you as a student, please do not do this in your answer sheets and your class books. Okay, don't do this. Don't keep doing this so that you can get a bold R. Okay, don't do this. This looks very untidy. What you can do is this. Just put a R and put a line right next to it, like this. One line is more than enough. So it's going to be like this, and then a R. Many textbook actually follows this. Some textbooks make it a bold R. Some textbooks write this to tell you that he's talking about a real number R. In fact, your natural numbers also. What is the meaning of this? This is a capital N. How do you know this is a natural numbers N? They put a line next to it. This tells them or the reader that the person, the author, is talking about a natural numbers N. So this is what you can do in your test papers. You can just do this to tell the reader or the person who is correcting your paper that you are actually writing a real numbers R. Some textbooks don't actually do that. Then it becomes a very tedious job to identify if it is a real numbers R or a natural numbers R or a relationship R, or you might have just not noticed this thing, but this is what it is. So that's the first thing. Now the second thing that you need to identify is that this function which is given to you, which is f of x, is equal to 2x. Okay, now here this is my elements from the first set and this is my elements from the second set, or the range. Okay, now normally when we are talking about functions and relations, we have two different sets. One is the first set, which is the set from where I'm going to pick up the elements or the domains that I'm going to be picking up, and then I'll have another set which is a set from where I'll be picking up my range. Now in this case, both are real numbers. Both are real numbers. Okay, now what is this going to have? This is going to have all the elements, the decimals, rational numbers, irrational numbers, everything in this. And this also is going to have everything like the decimals, rational numbers and the irrational numbers and everything in it. Okay, now if I'm picking up a element from here, I'm going to be connecting that element to an element which is twice of it. Okay, that is all the basic funda behind this question. Alright, now so if it is only that much, I wouldn't have picked up this question. Okay, what I'm going to try doing here is to explain as to why exactly the method that you follow works. Okay, let's say, for example, what do? You would have already known this, or your lecturer would have taught this to you. You know, for 1 1, if you have to prove 1 1, what you do is you take x1 comma x2 belonging to the first set, which is the real numbers itself. Okay, and then you say let f of x1 be equal to f of x2, and then what is f of x1? 2x1, which is equal to 2x2, which means x1 is equal to x2. And then you say if you get x1 is equal to x2, then you can directly go ahead and say that the function is a 1 1 function. Okay, now let's see why this actually works and why is it true. So I'm going to take a set here. Let's say this is real numbers itself, and I'm going to consider another set here. Let's say this is also real numbers itself. Okay, now let's pick up an element x1 in this. Let's pick up another element x2 in this. Okay, I'm picking up two elements from the first set. Okay, now I'm going to take the image of x1 as, let's say, y1, and the image of x2 as y2. You need to understand there are more elements here. There are like innumerable, uncountable elements in both the sets. Okay, now what I'm going to do is, okay, we do know that f of x1 is equal to y1 under this particular relation, under this particular function, and f of x2 is equal to y2, isn't it? What I'm going to do right now is this. This is connected like this, and this is connected like this. Okay, what I'm going to do right now is to say that y1 is equal to y2. So I'm now putting a condition that y1 is equal to y2. When I say y1 is equal to y2, what's going to happen? This is now going to go away. Rather, that's going to become a y1 itself, which means x2 is now getting connected to y1, which means now it is not a 1 1 function. You getting me? So I'm actually trying to tell that this, let us consider that this is not a 1 1 function. You getting me? So I'm actually trying to say that this is a onto function. Okay, so y1 is equal to y2, which actually implies that f of x1 is equal to f of x2, isn't it? So when f of x1 is equal to f of x2, that actually means that 2i's of x1, which is a function actually, is 2i's of x2. So we also know that 2 and 2 will get cancelled, so I get x1 is equal to x2. So what is this trying to tell me? That these two elements are not different elements, they both are the same elements, which means that I can now remove the repetition. And simply say that this is the true statement. You getting me? So I've just gone ahead and proved that this actually, if this is true, if for some reason this function was an onto function, it simply goes ahead and proves that the pre-images are the same, and hence it is a 1 1 function. You getting me? This is the background of what actually happens here. 3 lines means this. Okay, now let's that's exactly why, you know, after this you go ahead and say therefore you know, f of x is a 1 1 function. You getting me? Now let's go ahead and prove for an onto function. Okay, for onto. Okay, let me write the proof that you probably would be following at your colleges or schools. What do you do? First of all, you take let y belong to the second set, which is in this case real numbers itself. Okay, and then you say let f of x be equal to y, and then you would have gone ahead and said 2x is equal to y, so x is equal to y by 2. This is what you would have done, correct? Now after saying it's equal to y by 2, what do? after saying x is equal to y by 2, you now try to find out f of y by 2. What is f of y by 2? 2 into y by 2. 2x, isn't it? So instead of x, I'm going to write a y by 2. So 2 and 2 will get cancelled, you get a y. So when this happens, you go ahead and say that's a onto function. F of y by 2 is equal to y. Therefore f of x is onto, or subjective function. The proof is pretty simple, isn't it? For 1, 1, what do? All you need to do is this. First of all, consider a set. Okay, consider the two elements belonging to the first set, which in this case is, this is the first set. I'm going to pick up two elements belonging to that, which in this case is the real numbers itself. And then you put a condition saying f of x1 is equal to f of x2. Now substitute the value for the function itself, this much. Okay, this much. Now once you try solving it and transposing it, if you get x1 is equal to x2, then your proof is done, and you can directly say that it is a 1, 1 function. Therefore R is a 1, 1 function. Now what do you do for onto? For onto, first of all, you take a image belonging to the second set, and then you say let again some pre-image x be equal to y. Now find this out. Find out x in terms of y. Now this is the equation. Now take this and find out f of this. If you get that to be equal to a y itself, then you can directly say it's an onto function. Okay. Now again, not every question will follow the same proof. I will be explaining to you why and when this actually proof will fail, and how do you proceed with that question. You approach the same question in a different way altogether. Okay, so let's now look at a different question. Okay, so what I have done here is to pick up an exercise question from NCERT. The function here has been defined from are real numbers, but there is a star next to it. It can actually be written as R naught to R naught. It basically means that this is a real numbers are except for 0. Okay, you need to remove the 0 and consider everything else. That's what it means in both the first set and the second set. And the function itself is defined to you as f of x is equal to 1 over x. Okay, now I'm supposed to be proving that this is a 1, 1 function and an onto function. I'm going to follow the same method and try and prove this to you. So how do you do this? Understand, now that we know the concept behind it, what we're going to do is just a mechanical way of proving this question. Okay, we're not going to go by the concept as if now. What is the mechanical way of doing it? First of all, take two elements. This is for 1, 1. Okay, this is for 1, 1. So first write for 1, 1. For 1, 1, let take two elements belonging to the domain belong to the first set, which is R itself. Now put the condition let f of x1 is equal to f of x2. Alright, and then substitute what is f of x1. F of x is equal to 1 over x, so f of x1 is going to be a 1 over x1, and here it's going to be a 1 over x2. Now when you reciprocate both of them, you get x1 is equal to x2. So therefore f of x is a 1, 1 function. F of x is a 1, 1 function. So what does that basically mean? That you have taken two elements from the second set, which is basically the images, and you have said that two pre-images get connected to the same image. That is exactly what you are saying here, and you have then gone ahead and proved that the pre-images are the same, and hence it's a 1, 1 function. Now next we're going to prove for onto. For onto. Now when you're trying to prove onto, what do? You take an image, let y belong to the second set, which in this case is again real numbers itself. Now you say some image or some pre-image x is giving me the image y. Okay, so what is that? 1 over x is equal to y. which means x is equal to 1 over y. Now you need to find out what is f of 1 over y. What is f of 1 over y? It's equal to 1 over x is the function, isn't it? Look at that, 1 over x is the function. So this is going to be 1 over 1 by y, which is going to give me y. And because I'm getting back a y, I then say therefore f of x is an onto function. You getting me? Okay, so that's an onto function. Now let's look at the second part of this question. So I've gone ahead and proved that it's a 1-1 function and a onto function. That's not a problem for me. However, look at this. It's saying, or he's asking us that if this is going to be true, if this result is going to be true, if the domain R naught or R star is been replaced by n and the codomain being the same. What is he now saying? He's saying consider the same situation, but please go ahead and change your domain. So now the function is from natural numbers to R star. Natural numbers is this and this is this. Okay, now let's see how to prove this. First of all, is it a 1-1 function? Okay, that's going to be a bit of task. Let me just think about it. 1 will get connected to 1, 2 will get connected to 1 over 2, 3 will get connected to 1 over 3. Why am I saying 1, 2 and 3? Because natural numbers are going to start from 1, 2, 3 and so on and so forth. You're understanding? That's exactly why I'm doing this. That, you know, let me just give it out here. Yes, it does work. If I'm not considering 0, because you know what happens, 0 is not belonging to natural numbers, and hence, so it's going to be fine. So for 1 1, what do? Let x1 comma x2 belong to the first set, which is my natural numbers in this case. Now I'm going to say let f of x1 be equal to f of x2. So I'm saying that it is not a 1-1 function but an onto function by actually saying this. So what is f of x1? 1 over x1 is equal to 1 over x1. So when I reciprocate this 1 over x2, when I reciprocate this, I get a x1 is equal to x2. Therefore I can now go ahead and say that f of x is a 1-1 function. Now I'm going to now try and prove that for onto. Now when I'm trying to prove onto, I'm going to be taking let well, I don't need to do a proof here. In fact, I can contradict and you know, kind of give an example and contradict that it's not a onto function. Now what do I mean by onto function? I mean that all the elements from the second set has a pre-image, isn't it? That's exactly what I mean. So 2 belongs to the second set, real numbers, isn't it? 2 is a part of a real numbers. But what could be the pre-image of 2? Any guesses? Nothing. You getting me? Because natural numbers are going to start from 1, 2, 3, 4 and so on and so forth. So whenever I take the reciprocal of it, I'm always going to get a fraction, except for this, which is going to give me a 1. Otherwise I'll always have a fraction, 1 by 2, 1 by 3, 1 by 4, 1 by 1 by 1 by 1 by. It's never going to give me a proper number like this. You understanding? And hence 2 will be left out. So here I have 1, 2, 3, 4, and here I'll have every decimal, everything involved in this. Now 1 will get connected to 1, but 2 will get connected to 1 over 2. 3 will get connected to 1 over 3. Now what about a number something like 0.15? Or, you know, even better, what about a negative number? What about negative 2? What about negative 1? This is never negative. Even if I take it reciprocal, it's never going to be negative. So which means all the negatives are left out and numbers in between are also left out, which means there's a huge chunk that is left out from the second set, and hence this is not a onto function. Okay, so that's gonna be my proof. Okay, so how do I prove this? -2 belongs to the second set R. Okay, but there exists no element in the first set, which is N, such that no element, let's call that as A in N, such that 1 over A is going to be equal to -2, as A is always positive. You getting me? Therefore f of x is not onto. Okay, now what I'm going to do is I'm going to try and prove this in the way that we did for the previous question. Okay, so I'm going to try and do that. I'm going to tell you something out of it. So what is the procedure for onto? We say let y belong to the second set, which is real numbers, and then let me say that f of x is equal to y. And what is f of x? 1 over x, isn't it? That's a function given to me. 1 over x is equal to y, which means 1 over y is equal to x. Then I find out f of 1 over y, which is giving me 1 over 1 by y, which is actually y. So it is true. You getting me? So it comes out to be y, and you'll be wondering, yes, I'm getting a y, so which means the function is an onto, but I've just gone ahead and proved that it's not an onto. You getting me? So be very careful with this proof, okay, with this type of a proof, because not all the time it's going to work. It is a good way of proving it, but it's not the way that you need to apply for every other question. You also need to go back and think, is it really a onto function? And if it is an onto function, then you can go ahead and prove this in this fashion. If it is not an onto function, then you'll have to give an example and prove that it's not an onto. If you have watched the videos on the relations, I would have explained to you how to prove a person to be a good person and a bad person, how that works. That is the same concept that we apply here. I just give a example and contradict the person and say, you know, this is not going to be working. I just contradicted that, so okay. With that, we're going to be stopping this video here. I'll try and upload few more videos on functions and different ways of proving it. You will be getting a few more questions from the same exercise, and I'll be picking up a few more questions from here and try and prove that for you. Okay, so as of now, we'll stop the video here. As I have been requesting you, please go through these videos, and if you find that there is some kind of an improvement that needs to be done, I would appreciate if you can give me a feedback on the comment section. And please do go ahead and subscribe to these videos. Ask your friends to go through the videos and subscribe to it. Thanks a lot.